Operations in blockchain. As I have covered in my previous course, there are many operations in blockchain. The validation of transaction, gathering of transaction for a block. So first the transactions are validated, then all these are gathered into the first the mining pool, then all these are gathered into a block with so to be mined, then broadcasting valid transaction and blocks. All these broadcasting is done into the network, the peer-to-peer network. Consensus on the next block creation. It can be POW consensus or anything, any consensus for the block creation, and chaining blocks, so that there will be a chain of blocks next to next, so that the all the inner blocks will have some kind of trust or consensus on them. Next we have participant roles. So in Bitcoin or any kind of mostly blockchains have two kinds of participants, especially Bitcoin. So in this, the first is the person or the people who initiate the transaction, the participants who transact over the network. It can be the senders, it can be the receivers. So senders send some money and receivers receive the money. So there are transactions going on in the network. So the participants roles are these, or there can be a different set of participants which are the miners who work to maintain the network. So they maintain the network by mining more blocks, verify, broadcast and confirm transaction. The miners firstly verify, then broadcast the transaction, then confirm the transaction. Then they create a block and the block reaches a consensus by some consensus algorithms. And this is also the same input and output UTXOs verified by the miner before accepting the transaction. So the miner basically verifies it. If all criteria maintained, then only the transaction is added to the mining pool. If the transaction is verified, then only it will be added to the mining pool. There is a mining pool from which the transactions are taken to put it in a block. So like that. Then transaction 0 is known as the coin-based transaction of the block, which is basically the miner's fee or the incentive given to the miner for uh, mining that block. And there is no input UTXO for this. Accounts. There are two types of accounts in Ethereum. One is the externally owned accounts and the other is the contract accounts. This is also known as smart contract accounts. So, what are externally owned accounts? These are the accounts that a person needs to join the network. To join the blockchain network, he will need an externally owned account. Then, an externally owned account are always controlled by the private keys. So, a person is basically having the private key of his account. So, if this is his account, then he will be having a private key generated at the starting when he created the account. And he has to keep this private key secret. Then for the interaction with the blockchain, this account is needed to perform all the transactions. So all the money or the ether, you can say, as the cryptocurrency, all is transferred from an externally owned account, and all the money comes into an externally owned account. So that's how people interact with the blockchain using these externally owned accounts. Then has a ether balance. These EOAs always have a ether balance from which it can debit or credit. Smart contract accounts or contract accounts. Contract accounts are controlled by the code and can be activated only by an EOA. So how this works is that you have a smart contract written. To deploy this smart contract, you will have to have a EOA, which is an externally owned account. Then you will deploy it. Once you deploy it, it acts as a contract account. If it is made so it can get money into it, it can receive money into it, it can hold money, and it can also give money. Like I have told you the example of a buyer and a seller. So if it takes money from the buyer, it will hold it till the all the conditions are met, and then only it will give it to the seller. It represents a smart contract. This smart contract is represented by the contract account. It performs operations of arbitrary complexity, manipulate its own persistent storage, that is, can have its own permanent state, and also can call other contracts. So in this smart contract, so as it represents a smart contract, it gets all the features of the smart contracts. So like it will have a persistent storage, it can have arbitrary complexity codes and all, and it can also call other contracts through it. It can deploy another one more a smart contract if given. It can call it also. And now this can also become a contract account. This is some kind of nesting going on out here. This also has a ether balance in which it gets money, holds money, and then sends money.